now let us see Newton's rings. So in Newton's rings, a plano-convex lens is taken and is placed on a plane mirror This is a thin lens placed on a plane mirror, and this is again the same. A converging lens can be taken up. At the focus of that lens we can have a parallel ray, and this will produce a parallel wavefront which when passes through a beam splitter will incident directly on this lens, and this lens again the rays will pass, again it will get reflected from the mirror, and so finally the rays will go towards this. Here there will be a screen. So in this way we study the Newton's rings. What happens here on the screen, you will form a discs. These discs are called Newton's rings. These are actually the interference produced by these light rays reflected from this air film. So this is what Newton's rings is and how they are produced. Now let us study how we will get discs and what are the radius and all such things. Now what happens, this is a plano-convex lens and I have placed this on a plane mirror. So suppose a ray comes here, this is a ray near normal incidence, ray 1. This ray gets reflected, this ray will be called ray 2. Then again it gets here, again it gets reflected, again here only it gets reflected and passes, this will be called ray 3. Again by this plane mirror it will get reflected and it is transmitted at 3. So I have 1 ray, 2, 3 and so this is 4th ray. So we have 4 rays. Now let us see which rays will interfere and produce the interference pattern on the screen. This is my screen. Here they are going to form some rings. These are Newton's rings. So first of all, this is the incident ray, this is the reflected ray, this 2 and 3, they don't interfere. 2 and 3, they don't interfere. 2 and 3 will not interfere. Why they won't interfere? Because I said this is thin lens, but even this thin lens, the thickness of the thin lens is very large compared to the dimensions of the wavelength of light. That is why interference takes place only when the distances involved here are compared to the wavelength of light. That is why 2 and 3 will not interfere. What about 2 and 4? Now this again this distance is large, although in my diagram it seems that this distance is large. This is my exaggerated diagram. Here the film, air film is there. This is air film, air, glass and air. So the ray 3 and 4 will interfere. The ray 3 will interfere with 4 because third wave is reflected from this point and fourth wave is reflected from this. That means here the air film is involved. So the air film formed between the lens and the glass mirror reflects the light and produces the interference, 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 and produces patterns. This is very important. Which two rays are going to interfere? Third and fourth. The interference patterns, the fringage on the screen will be circular, and at the center of the fringe there will be darkness. Why? Because at the center there is a point of contact here, there is no reflections there will be darkness. So, the very important point is that the interference is because of the reflection due to the air film formed between these two. So, glass here, this is an exaggerated diagram. So, this film, this thickness is large compared to this. Now, let us calculate that what is the radius of the dark fringes and what is the radius of the bright fringes, and why these fringes are circular in nature. So, now let us calculate the path difference between the two reflected rays. This is the plane mirror and this wave is here. So, this wave is reflected and here again this is reflected. So, between these two rays we have to study the path difference. So, this suppose distance from here is r and this is t. T is the thickness of the film here. This T is 0 here. As you grow on, the T grows as r increases. So, this is the distance r, and let the radius of curvature of this will be r. This has a radius of curvature r mirror. So, let us calculate T. So, suppose this is our radius of curvature, this is the center of curvature of the mirror, and you see this is the plane mirror what we have considered, and this is the center of curvature of the lens, this thickness is T. So, now you see, suppose this is r from here to here, this is r and this is also r. So, if I join this to here, then we have two chords. When two chords intersect, the rectangle contained by them are equal, means this into this is equal to this into this. This is by plane geometry. That is r into r is r square. This distance is t into here to here distance is total distance 2r minus t. So, if t is neglected, it will become 2rt. We can neglect this t. So, r becomes t into nearly 2r, because this thickness is small compared to the radius of curvature. So, r is equal to root over 2rt. This is r, or we can calculate t in terms of r by 2r. So, let us write like this. Now, again we see that the wave reflected here has a phase shift of pi. Now, this is air, this is mirror. So, during this reflection there is a phase shift of pi, but the wave reflected here is reflected from air. So, there is no phase shift of pi. So, here if path difference, what is the path difference here? Delta x is equal to 2 air has refractive index 1. So, simply 2t that is equal to r by 2r. If delta x is equal to m lambda, then destructive interference takes place. What is r in this case? R becomes 2 mr lambda. When m is equal to 1, then this is 2r lambda. So, sorry, here there is r square. So, it is r square. So, r square is this. We can write will be root over 2m r lambda. This is the distance mth distance of the darkness. That means, you see, this t, suppose this t is the path difference. So, this is a whole circular path. So, along the whole circular path, this path difference will be maintained. That means, on the screen, the radius of the mth darkness becomes 2m root over m r lambda. When m is 0, then there is a central point, that is the darkness. When m is equal to 1, this is 2 r lambda. So, we see that the distance of the mth dark circle will be root over 2 m r lambda. And if for brightness, now if this path difference, that is 2t, is equal to r square by 2r is equal to 2m plus 1 lambda by 2, implies r becomes root over this 2 cancels, then r lambda 2m plus 1. So, when r, this is r mth. So, this is the radius of the brightness, bright circle, bright fringe width, bright fringes from the center. So, you see the radius is proportional to here m, root over m for darkness and this for your brightness. So, thus we see that on the screen we will get circles. So, let us draw it somewhere here. So, the nature of fringage will be at the center there will be a darkness. This is darkness. Next darkness will be like this. Next darkness will be like this. Actually, it cannot be drawn by my marker because there will be region of darkness and brightness. So, white one shows you some brightness, darkness. So, the radius, this is r darkness and this is the brightness, radius of the brightness. So, the fringes are circular in nature. Important point, at the center there will be darkness, and so the radius of the dark circles will be root over 2m r alpha r lambda, and for brightness it will be like this. This is how Newton's rings are formed.